I'm not that crazy. I went 170 and 55. That's a 2-lane road. I don't have a death wish. This is seconds here. This is miles. So, see if you can figure it out.
I was like, dang, she covered 70 miles in 10 seconds.
Remember, too, I'll put this up here, that your speed is your miles per hour. So it's the miles distance divided by hours, which is time. How fast is it going?
51.4296.
I think it's right. You're close.
Another way. I even did this.
Go ahead and do the second one also. Unless I did this wrong on mine. I will tell you, you don't have to estimate this because I was going the same. This is a straight line right here. So I was going the same speed from here all the way to here. So I would not try to estimate what's here. You may have done that. I would use these two endpoints that I know for sure. Yeah, so that's probably why yours is a little bit off. You're probably doing the right thing, but you used the estimate. So I went 0.3 miles in 20 seconds. All right, anybody got a speed? Probably. I mean, I got 54 even. I might have rounded it. Anybody else get 54? Okay, let's go through how to get this. Okay, so I went 0.3 miles in 20 seconds. But the problem is if you divide this, it's going to give you my speed in miles per second instead of miles per hour. So in chemistry, you should have learned how to convert units. Was that last year or 2 years ago? It was during COVID 2 years ago. Yeah, okay. So to convert units here, you need to know how many seconds are in an hour. How many seconds are in an hour? 3,600. Okay. So you have seconds on bottom, which means you want to put seconds on top. And you want to change seconds to hours, right? So 3,600 seconds equals 1 hour. So if I'm multiplying by 3,600 seconds over 1 hour, it's really like I'm multiplying by 1 because it's something over itself, right? But seconds is going to cancel with the seconds on top. Just like if you had an X on top and X on bottom, they'd cancel out, right? So if you multiply straight across, if we pull up this calculator over here, if we multiply, I don't know what that is or why. 0.3 0.3, oh wait, 0.3 times 3,600. I don't know what that stupid block is. It's making it so I can't. Oh, it's because I'm recording. That doesn't usually show up. That's annoying. Doesn't want to let me make it smaller. Alright, so you get 1080, and then you divide that. So you're going to have 1080. You don't have to write this down. You can do it all in one step. 1080 miles, because miles is all that's left on the bottom. 20 hours. Divide by, divide by 20 over here. And you should get 54 exactly.
Yeah, I did like 3,600 divided by 20, and then I multiplied that by 23. I didn't use 3,600 like that, and then it gave me exactly.
That'd be the same thing though, right?
Yeah, it's just the seconds divided by the other seconds, and then you multiply it by 23 miles.
You can do it however you want, but it's the same thing. I like this because it you can do it even if you have units that you're not familiar with, that you don't know very well. All right, so the second one, right? I went. How far did I go from right here to the end? Just 0.1 miles, and it took me 15 seconds. Right? Because I'm going from 0.3 to 0.4. And then it took, these are going up by 5, so 5, 10, 15 seconds. And so we got to do the same thing here. We got to multiply this by 3,600 seconds over 1 hour. So 0.1 times 3,600. It's going to be divided by 15. So now, we're going 24, and I should put miles per hour here. Good job. Okay, so that's my speed at these two places, right? We can figure that out. How fast was I going when I was 0.3 miles from the speed limit side? Right here. How fast was I going there? Or was I going 24? I just quit going 54 and started going 24, right? So we don't know how fast I was going. So is this actually possible in real life? For me to go from going 54 to immediately going 24? I mean, there's always got to be a deceleration, right? Even if it's super fast, it might almost look like that, but I still had to decelerate, right? So, I mean, I guess you could go from that to 0 pretty quick, but to 24, you're still going to decelerate, right? So this is not possible. So I've asked a question that might get us sidetracked for a minute, but this question right here cannot be answered, right? We can't answer that. Because I can't be going 54 and 24 at the same time. I can't go directly from going 54 to going 24. So this graph right here is not realistic. It's not what's happening in real life. I was not rolling along going 54 miles an hour and then immediately went only 24. So, no, I didn't get out of this one. Oh, I did get out of it because I hadn't had a ticket in a while and I got it reduced to improper equipment, but
Did you see Miss Hyatt making her dress on
alright, so look at your next slide. Alright, everybody look at your next slide. This is more what the graph should look like, more or less, right? I was going at a constant speed of 54 miles per hour. Way too late, I saw the speed limit sign and realized I needed to slow down. And then right here, there should be sort of a smooth curve, right? that where I didn't go from 54 to 24. I slowed down over time until I got to 24. So, for the questions here, at 0.1 miles from the speed limit right here, the answer's still the same. I was going 54 miles per hour. I'm not going to make y'all redo it. I didn't change the graph or anything in that section. I'm still going 54 miles an hour. Over here, at 0.35 miles from the speed limit, I'm still going, was it 24? Still going 24 miles per hour. Okay, so right here, at this point right here, which I'm going to say is maybe where the cops saw me, right? Because I was probably not going, I think he wrote it for 51. And I was probably not going 51 and a 55. I was probably going at least 54 and a 55. I was probably going maybe a little more than 54 and a 55. But not much. So right here, where I'm going to say is probably where the cop saw me, I could estimate how fast I'm going. And so what I could do, and this is where we're getting into calculus, right? What we were doing on that first question with the jagged graph where I went straight from 54 to 24, that was a pre-calculus question. Because for the first two questions at least, you could answer that exactly, right? You could tell me exactly how fast I was going. But right here, my speed is not constant. I'm decelerating here, so my speed is changing. So this is where calculus needs to come in. So what I'm going to do here is I'm going to draw what we'll learn much, much, much more about throughout this class. I'm going to draw a tangent line. I'm going to draw this line right here, okay? I'm going to draw this in. It's going to be a line that touches just at that one point. So at this point here, let me make it green too so it shows up a little bit better. At this point, my speed can be shown by this line right here. So on this line, I'm going to have to do some estimations because this is not perfect. But let's say that's pretty close to being right there. I'm going to draw this on out here. Let's see if I can get this to work. No. If I'm not estimating well, this might actually turn out not so great, but let's try it. Let's say we're going from this point right here up to this point. So the distance, that vertical distance would be 0.25. We're going to say that's about halfway miles. And then the time would be 5, 10, 15, 20, 25 seconds. So I can do like I did on those other problems. And I've got 0.25 miles divided by 25 seconds. But I've got to change it to miles per hour. So if we do that here, right here, this was at 1.15, and then so that'd be 0.5 or 0.05, and then 0.1 and 0.1 here. So that's like if this is at, this would be 0.15 here. You're subtracting that from that 0.4. Yeah. And so I shouldn't even have to do this. This is point. Oh, this is going to be 36. All right, so I'm getting right here 36 miles per hour. This was probably actually a little bit after the cops saw me because I was probably, he might would have not given me a ticket. I don't know, I was already in 25 by that point, so maybe. But, so we could estimate 36 miles an hour. All right, we could estimate based on this graph. This probably isn't the greatest estimate because, we could kind of, I just drew in that line by sight, so it probably, it's not exact. But if I had an equation for this, and I knew the equation of that line, then I could find that exact point using calculus, and I could find that rate of change. So calculus is eventually, whenever we learn it, going to allow us, if you know the equation, to find that exact rate of change. Which you're probably not going to have for me driving down the street getting a speeding ticket, but you would have in, say, like, if you are testing, like crash testing cars or something, you probably have their exact speed and could sort of look at that stuff on the graph if you had really high-tech equipment. Yes, Thomas? Yes. Not if we just had, if you had the equation of the green line, yes. If you have the equation of the black line here, if you plug something in, it would just give you distance. It would not give you speed. So you could find the average speed pretty easily without knowing calculus, but if you want to know the speed at that exact point, then you would have to have calculus. So like whenever, like if you get a speeding ticket, that cop had a radar gun and he shot my car with the radar gun, and it told how fast I was going at that exact moment. It didn't matter if I had, didn't matter how far I had gone, or, like an average speed. Right. Like you could drive from here to Winston in an hour, and your average speed might be 55 miles an hour. That doesn't mean that you didn't get up to 95 on the bypass, right? So your average speed may not be speeding sometimes, but that doesn't mean you didn't get up to 95 at some point, right? Don't go 95 on the bypass. All right, let me take you to my other speeding ticket. Here we are. Usually at this point, somebody else tells me about the speeding ticket they also got right here.
Oh, yeah. I always thought that place was 45.
Yeah, it's just 35 right here. Watch out. I will tell you that I was going up the hill whenever I got the speeding ticket. I was not going down, which makes it worse. I would have been better off now because I take Henry to daycare up here every day. Just right back here is Henry's daycare. But this was several years ago, and I was going to pick Hunter up. And I didn't usually go this way because he went to a daycare out in Trap Hill and on Austin Trap Hill Road, not really all the way out in Trap Hill. And I was going up the hill. So my excuse for going way too fast through here. I was saying, usually when I show this, somebody else tells me about getting pulled over right here as well. So I will maintain that both of my speeding tickets have pretty much been in speed trap areas and not where they were just out to get, not actually really dangerous driving. I know. But, so, huh? Yeah. So, watch out right here. Right over here on 268, they'll get you. Because it feels like right here it should be 45. But it's not. So this is the other spot that they got me. So, this time, I have made another graph of my speed. Or not speed, of the distance I've traveled. Okay? So, first question, was I traveling at a constant speed over the interval shown?
No.
No. What would it look like if it was a constant speed? Straight line, right? Is it possible to travel, if this is, because I was at central office, and I got the ticket up at the top of that hill, is it possible to travel at a constant speed from central office to the top of the hill.
No. Cruise control. Legally? No.
It is not possible because you are stopped at central office and you stop at the top of the hill. So you must accelerate to get to a... Now, it could be pretty straight in the middle, but
I finished the rest.
then you might run the stoplight and get killed in that intersection. So, stop, Chandler. But you cannot run a constant speed if you start and stop at the end. Now, if it were... Yeah. Now, the middle section could be constant. Okay. All right. About what time interval, look at the graph, about what time interval do you think I was going the fastest? 70 to 80, so 50, 60, 70. Right here. 40.
You want it to be in the middle. Extending over the entirety of the rectangle triangle.
I think I'd go 70 to 80. But I will admit, anywhere from probably about right here to about right here, this is pretty linear right here, right? So what are you looking for when you're looking for when I was going the fastest? Steepest on the line, right? So I was going pretty slow right here, right? I was stopping, and then I realized there's blue lights behind me when I hit the stoplight. So I was going pretty slow right there, which I shouldn't have said, because what is the slowest I was going on? Which interval was I going the slowest? Let's see, this is 120 to 130. Right, I'm going pretty slow there because it's not as steep. All right, so let's say that we have this information here. Okay, so this information, those are those exact points graphed. I put these points into Desmos. That's where the graph came from, right? So these are those points graphed. So let me put the view right here. Dual page display. There we go. Okay. So let's estimate my speed for the whole trip. So if I want to know how my average speed for the whole trip, I just need distance divided by time, right? So my distance, I started off at 0, went to 7,530. And this is feet. And that took me 130 seconds. I want to know this in miles per hour. So this is seconds, so I'm going to have to do like I did on the last one. I'm going to have to do 3,600 seconds over 1 hour. I've also got to convert feet to miles. So feet is on top. I need to put it on bottom over here, right? And feet, I'm changing that to miles. How many feet are in a mile? 5,280. All right, so feet is on top. It cancels with the feet on the bottom here. Seconds is on bottom. It cancels with the seconds on top here. That leaves you miles on the top and hours on the bottom. So that means your answer is going to be in miles per hour. Okay. So to do this, on the top you've got 7,530 times 3,600. And I'm just going to do this all together. I'm going to do divided by. On the bottom, you got 130 times 5,280. And, here's an example of when you really get aggravated at this calculator. Hit the green button before you hit enter. So I got 39.493. Well,
No, it's average.
no. That's my average speed. He probably would not have pulled me over if I had been going 39.493 miles per hour, right? Usually it's got to be more than 5. I mean, technically, yeah, I was speeding, but not that much. However, he didn't care what my average speed from Central Office to the top of the hill was, unfortunately. He cared about, because that's probably going slow by the park. By the park seems like you should be slower around the park, right? It's up that hill that got me in there. So let's estimate my speed 20 seconds after I left Central Office. Okay? So let's think about this. If we're going to estimate this, I'm going to go back to the graph real quick. 20 seconds after I left Central Office, we're talking about right here. Okay? So if I'm estimating that time, I don't want to know the average speed of my trip to that point. I want to know my speed right then. Okay? So if I want to estimate this, I want to estimate really close to that point, right? I don't want the whole length of the trip. I want it really close to that point. So what I would probably do right here at 20 is where I'm trying to estimate. I would probably use the points very close to that. So I'd either use like 10 and 20 or 20 and 30, or I think what I'll do is use 10 and 30, right? So if I'm looking at what's happening right here, okay, just this little section, how far did I travel?
Why do you use the last one, the 1 mile, 5,200? Oh, we can't do that.
To cancel out feet, because you want miles per hour instead of feet.
Oh, okay.
Yeah. 990 feet. Is that right?
Yep.
Oh, I think I did it different over here. Where is this? Okay, yeah. So 990, because we're just taking 1440 and subtracting 450, right? So we got 990. Let's see, I'm on right here. This is 990 feet. And how many seconds did it take? 20. So let me flip back over here. So let's do 990 feet divided by 20 seconds. We got to convert here also, so we got seconds on top, hours on bottom, and then we've got 1 mile, 5,280 feet. Feet cancel, seconds cancel. Let's see, we're going to have 990 times 3,600 divided by 20 times 5,280. Be careful right here about it. I need 135 divided by 4. So you get 33.75. So this is probably right there in front of the park. This is probably how fast I was actually going, more or less. I was probably going 35 in front of the park. More or less. Okay? But what about if we want 65 miles per hour? At 65, which was fall between 60 and 70 here, right? That takes 10 seconds. And we've got, what is it going to be? 750? So I've got 750 feet. And we're just subtracting those to find that. I'm moving a little fast because we're out of time. 10 seconds. And just like the others, we got 3,600. 1 hour. 1 mile. 5,280 feet. So we got 750 divided by 10 5,280. Green button before you hit enter. Oh, I didn't hit the green button. Green button before you hit enter. Hold on. Oh, I've got 7,000. Let me not going 528 miles an hour. I would not be here today if that was good. All right. 51.1364 miles per hour. About the same as my other ticket. Too fast for a 35 mile per hour. I was going up. If I was going down the hill, I'd feel a little more justified, but I never went that way. Yeah. I never went that way. Not really late. No, he went to a different daycare out on Austin Trap Hill Road, so I never went that way. So I was not familiar with the speed limit through there, and obviously not paying very good attention. And I was going way too fast. So those are my 2 speeding tickets. Drive sensibly. Don't drive like Miss Hyatt on these 2 particular occasions. Actually, at this point, I had Dodge Ram that I drove every day because I was driving my husband's truck every day. It was a little bit cooler than my mini. Actually, wrong. My minivan is so cool. My minivan is better than a truck. You can take it home if you want. Calculator keep with you. Don't leave it in here because it'll get gone. But the book is up to you. You can leave it under your desk or take it. All right, hold on just a second.
A couple of announcements before the day finishes, before the bell rings. Remember our dismissal procedures. The first bell that will ring at 3:10 is for student drivers, those students who are parked in the student parking lot, or someone riding from somewhere in the student parking lot. Bell will ring at 3:12. That is for car riders if you're being picked up in the car line at the middle school. Buses, if you ride a bus, it's 84th period class. Until we make an announcement, we'll make an announcement. All the buses are here and ready for them. Thank you, students, for a great first day, smooth first day. Appreciate that. We look forward to seeing you again tomorrow.
This is not the homework that's posted on Canvas. I gotta fix Canvas because we took a little longer on the notes, which is fine. So this homework, actually, you will need your book, or you will need to take a picture of page 58, 59, and 60. Right? So if you want to take a picture, that's fine. It'll weigh less than 58 or 60.
I'm afraid I'm going to accidentally cut off.
And this is just a little introduction. This shouldn't take you more than 10 or 15 minutes to do. I do not expect you to spend this much time. But it's just read one page and answer these questions. Yeah. Or you can have any else.
They say 15 minutes.
I'll be here in the mornings on Mondays and Thursdays.
Does it have like Sherry classes?
Yeah, I can stay after a little bit. There might be some days I can't, but just to get with me.
I need a binder, I think.
Yes, please keep them with you. Your calculators go home. Oh, and please wipe off your desk. Let's see. Eli, would you mind giving everybody a
So I guess now that means we won't be submitting many things through Canvas as we did
Hopefully
last
not.
year.
Hopefully I'll just check with my Yeah, there'll still be some things we do online, like we use AV Classroom some. You'll do some stuff online there, but most stuff I'll
It won't be
in
like
class.
filling out papers and scanning them in.
Yeah, it won't be like
Yeah,
taking
okay.
pictures of your homework. Hopefully, unless you're out. Unless
Yeah.
you're out quarantined, then you have to do that. So.
Really strong.
Yeah, they're like They make me feel like I'm about to get a shot because they smell like those alcohol pads they use.